They were cut out of tubes and then welded together. And that's true for the software too. A lot of these teams have to design and build their own software. So, okay, we see movement on the left side. That's the Washington Bothell robot. So these teams have 10 minutes to run. It looks like we got our camera views back. On the bottom of the screen, you can see the students, the Bothell students on the left and the Milwaukee School of Engineering students on the right in the control room monitoring the progress of their robots. In some cases, they're controlling these robots. In some cases, they're just hitting a start button and the robots are controlling themselves and making their own decisions. It's really hard from our perspective to know which of those two things is happening. But we have judges in the control room who are quite aware of whether the students are running in autonomous mode or if they're running in manual mode. So again, Washington Bothell on the left has moved. I haven't seen any obvious movement yet from Milwaukee School of Engineering. And with only 10 minutes in each run, it is important to get these robots moving right away, because every precious moment is critical to your score. So the Bothell robot on the left has a tracked mobility system. They're using tracks like a crawler vehicle. And they have their digger is basically like a backhoe.
It's crossed into the digging zone now.
There on the right side, you can see the Milwaukee School of Engineering robot actually moving its digger mechanism. So they are able to command that robot, it looks like. This is part of the troubleshooting phase. When your robot doesn't start driving, well, you need to figure out why. And so you can try commanding some of the other parts of your robot at that point in order to figure out where things are breaking down. You can prove whether or not communication is happening successfully by trying to command other parts of your robot. This is Washington Bothell. They have a really nice looking backhoe there. It can, it's on a 360-degree spinning platform there, so they can basically choose any direction to dig that they want to and then spin that around and dump it on board. Not sure what's going on there. Okay, that was probably on purpose. So the rocks that are the scoring material for this competition are buried under the surface. And so you'll see a lot of robots in the competition this year. When they start digging, they basically just throw that stuff away because they don't care about the topsoil, because it's not worth any points. So I think that's what you just saw from the Washington Bothell robot. The point here, that's a good scoopful. The point here this year is to dig as deeply as possible and to pull up some of those rocks. I'm not sure why the robot does that. That seems like a waste of time. I'm not sure if that's on purpose or not. So the deeper this robot can dig, there's a nice scoopful right there. The deeper this robot can dig, the more points they'll end up getting for the mining portion, at least in the mining portion of this competition. So at some point, I just realized the students are actually not able to see this angle. We're looking at the front end of the robot, but the camera that the students are provided is actually from the lander's perspective. So that camera can only see the back end of the robot right now. So we have, from the spectator's perspective, we had a lot better view. Okay, it looks like I guess they dumped one on board. I wasn't looking.
There wasn't anything in there, unfortunately.
Okay. Well, if they're looking at their cameras, then they should have been able to see that. so I'm not sure what they're doing now. Again, this is University of Washington, Bothell. And on the right side, a robot that we haven't seen move other than their bucket ladder, their internal bucket ladder system. We did see it spin earlier. That's Milwaukee School of Engineering on the right. So I kind of made a comment earlier about, I don't know why the robot's doing that. Why is it doing that? But if it's in fully autonomous mode, there you go. That's why it's doing it. Because, you know, it's software, and it's making decisions based on sensors, and none of this is perfect. And so it's hard to know whether these students are driving this robot or whether it's running autonomously. You can see a student on their laptop there, but that does not guarantee that they're manually controlling this robot. They could be just using that laptop to look at the data coming back. Only the judge that's sitting in the control room knows for sure if they're running manually or if they're running autonomously. My guess would be autonomously, though. So even if an autonomous robot does something that seems counterproductive, a lot of times the students will not intervene even if the robot is doing something that's counterproductive, because if they let it continue to churn and run and eventually it makes progress, that actually gives them a really good points advantage if they run a run completely autonomously. So even if the amount of rocks that they end up getting is lower, they can actually end up getting a bigger score overall due to just the autonomy score, because autonomy is worth a lot of points in this competition. So sometimes we see things on the video that don't quite make sense, but then when you learn the entire background and understand all of the information and all of the decisions that the students have to make, then it finally makes sense. In this view, seeing the Bothell students in the lower left of your screen, the student on the right has their hand on what looks like a joystick, but it should be noted that these students can control their NASA camera view with what looks like a joystick. So sometimes when it looks like a student is controlling the robot because they're moving a joystick around, a lot of times that's just the NASA camera view, the pan, tilt, zoom camera that they're controlling with that joystick. Now the robot on the Bothell team has gently touched the side of the arena a couple times there. So it may be confused about where it is and where it needs to go. On the right, that's the Milwaukee School of Engineering robot. And the view, the camera view on the lower right that is kind of a low resolution, that's the camera view that the students, the Milwaukee School of Engineering students, are controlling in the control room. So you can see that those students are zooming way, way into their robot as part of their troubleshooting process, I'm guessing. 1 minute 13 remaining in this 10-minute run from both of these teams. So if things start working, there's still enough time in this final minute for the Bothell robot to go back to the hopper and dump whatever it is it's carrying on board. Sometimes you'll see students take over manual control toward the end of their run, and sometimes you won't. It all depends. This is a decision that they have to make individually as a team. So we're in the last 15 seconds of this run. So even though neither of these robots were able to deposit any of the scoring material, there it looks like Bothell has taken over manual control just in the last few seconds to verify that their dumping mechanism works and to give us a demonstration of that mechanism. Be interesting to see if anything falls out of that thing, because we didn't really see them dump anything in there. No, I don't. It's hard to tell from this camera, but it doesn't look like there was anything in there. So even though neither of these teams ended up scoring, let's